Okay, good evening, my dear students. Welcome to the largest online platform, Unacademy, my dear students. Okay, myself is Dr. B.N. Rao, having 17 years of the teaching experience, my dear students. 17 years of the teaching experience, my dear students. Okay. And from the last 17 years of the pure academic experience, my dear students. And out of these 17 years, from the last 10 years, I was supposed to be involved completely in the competitive examinations for teaching the examinations like GATE and engineering services, my dear students, in the domain of communications, core instrumentation, electronic device and VLSI design in the departments of communications and instrumentation, my dear students. Nearly I dealt 200 plus batches across all the locations of the India, covering the northern and southern parts of the India. Recently I have received the PhD in the department of ECE under low power VLSI design from one of the reputed University of Andhra Pradesh, my dear students. This is about my profile, my dear students. Similarly, when comes into the Unacademy subscriptions, two important subscriptions are there for Unacademy. One is called iconic subscription. When you are going to take this particular subscription, my dear students, it is one of the biggest and the beautiful subscription, my dear students. If you are going to take this particular subscription, a personal coach is dedicated for each and every student, my dear students. And a detailed study plan is present regarding the his or her subject as well as the GATE and engineering services competitive level examination. Moreover, you are going to receive the expert guidelines from the topmost educators of the Unacademy, and you can practice the mains level guidance, my dear students, as well as the engineering service is concerned. Similarly, for plus subscription is concerned, my dear students, this is the second subscription after iconic, which is a beautiful one. If you are going to take this particular subscription, you can practice unlimited test series over here, my dear students, with respect to the structured timetable, my dear students. Here also, when you are going to take this particular subscription, you can access the live classes from the topmost educators of the Unacademy for different subjects or different competitive examinations in different languages, my dear students. This is one more important subscription. Just I would like to bring it to your notice, my dear students, before entering into the next subscription. So these are the important parameters. Just I would like to bring it to your notice, my dear students. Similarly, these are all the fee structures of the detailed subscriptions, my dear students. If you are going to take it for the the plus subscription for GATE and engineering services, as I told you, that is the fee structure itself is 27,225. And my dear friends, that is again for the gate and engineering services for 18 months, my dear friends, for the plus subscription, the fee structure is 34,650, and you can use my code and get the discount. Okay, similarly for 24 months, for the same plus subscription, the fee structure is 39,600, and you can use my code and get the discount, my dear students. Okay, similarly for gate and engineering services, for iconic subscription, my dear students, for 12 months, the fee structure is 25,225, and for the same iconic subscription for 24 months, the fee structure itself is 66,600, my dear students. Okay, good evening. Okay, so these are all the subscriptional details. Just I would like to bring it to your notice, my dear students. Similarly, the plus batches taken by the, that is inside of the Unacademy plus subscription, my dear friends, okay, by the topmost educators in electrical and EC departments, my dear friends. Target engineering services prelims 2021 electrical, already it has been started in December 7th. Next rank booster batch for gate 2021 batch day, okay, it is also started November 30th. And target engineering services prelims 2021 electrical November 20th it is started. And rank booster batch for gate 2021 batch B, it is also started and it is running successfully, all these batches, my dear students, from the last 1 month. Okay, and these are all the faculties who are going to take the various subjects in the Department of EC and electrical inside the Unacademy subscription. Okay, similarly there are certain other batches that has been launched, okay, in the last week only, my dear friends, and these particular batches are called Ascend, my dear friends, for gate 2023. Ascend for gate 2023 ECE batch A, that will be English and Hindi, 21st of the December, my dear friends. These are all the faculties who are going to teach you the subjects. Okay, and similarly there is one more Ascend for gate 2023, and it is a batch A. It is also English and Hindi, starts on 21st of the December, my dear friends. Okay, these are all the faculties who are going to teach you the subjects, my dear friends, as far as the electrical batch is concerned. Similarly for EC batch, okay, electrical batch Evolve for gate 2020, it is also starts on 21st of the December, my dear friends. Okay, and this batch is also running successfully, my dear students. Okay, similarly one more batch for Evolve Gate 2022. This is also taught in English and Hindi, and it is a EC batch, my dear friends. These are all the faculties who are going to teach you the subject, my dear friends, in a detailed manner. My dear friends. Okay, all these particular batches are taken by the inside of the plus subscription. Okay, similarly as far as welcome to Telugu Unacademy Telugu channel once again. Okay, so here one more important thing I would like to bring it to you, Unacademy Telugu channel tarafuna. Good evening, my dear friends. So very important things just I would like to bring it to your notice is that Unacademy GATE crash course. Okay, it is already started 3 months back and it running successfully only in weekends. Okay, from 4 p.m. to 6 p.m. the core subjects of the, okay, EC and electrical. Okay, weekdays the faculties like Bhim Shankar, okay, teaching the networks and digital electronics, and Professor Krishna is teaching, my dear students, the subjects like mathematics and foundation mathematics, and aptitude faculty, most reputed faculty is teaching the aptitude, and myself in weekdays I am teaching communications and weekends CDC, and Bhanu Shankar sir or Bhanu Prakash sir is teaching, my dear students, the subjects, okay, like machines and power electronics, and one more faculty Surendra sir is teaching the power, okay, systems, my dear students. Okay, similarly the complete December month schedule as far as Unacademy Telugu is concerned, my dear students, this is also very important. Just I would like to bring it to your notice over here. Okay, over here, my dear students. Okay, similarly as far as Unacademy, see here, this is the subjects that are running successfully. Okay, in weekdays communication systems, the timings are, okay, 4 p.m. to 5:30 p.m. machines, 4 p.m. to 5:30 p.m. engineering mathematics, 5:45 to 6:45, Power system 7 p.m. to 8 p.m. aptitude, 8:30 p.m. to 9:30 p.m. and the weekends power electronics 4 to 6 p.m. and DDC 4 to 6 p.m. and aptitude 7 p.m. to 9 p.m. my dear students. Okay, these are all the various subjects that are dealing by the various top most educators of the Unacademy Telugu channel, my dear students. Okay, as I told you, this is a weekend EDC crash course, my dear students, from 4 p.m. to 6 p.m. my dear students. It is also running successfully from the last 2 months, my dear students. Okay, similarly these are all the general things. Just I would like to bring it to your notice before entering into the subject. Okay, similarly Unacademy combat, my dear students, once again one more important combat: compete, crack and conquer. Okay, another combat, my dear students, which again on December 29th at 6 p.m. my dear students. Okay, you can win the exciting prizes and the rank. Okay, ranks 1 to 3. Okay, you are going to get the 3-month subscription of the Unacademy. Okay, and the ranks from 4 to 50, my dear students, you are going to get the 500 rupees Amazon vouchers. Okay, and it is India's largest fortnight competition for GATE examination, and the questions has been created by the best educators and super fast and fun with the real-time rankings, and compete with the best and detailed video solutions by the top educators. Okay, and the detailed video solutions by the top educators, my dear students. Okay, similarly Unacademy combat, my dear students, that is also 6 p.m. December 29th, my dear students. Okay, and this is also, I told you that what are the things I brought it to you, like the previous combat ఎలా జరిగిందో ఈ combat కూడా you are going to have the very beautiful combat, my dear students, that is also commencing soon on December 29th, my dear students. One more combat. Okay, similarly so ఇదంతా కంప్లీట్ అయిపోయింది అలా ప్రీవియస్ సెషన్లో. మనం ఇవాల్టి సెషన్లో వీఆర్ గోయింగ్ ఫర్ ద నెక్స్ట్ కాన్సెప్ట్, మై డియర్ స్టూడెంట్స్. ఓకే, అంటే స్పెషల్ పర్పస్ ఎలక్ట్రానిక్ డివైజెస్లో వీ హ్యావ్ ఫినిష్డ్, మై డియర్ స్టూడెంట్స్, ఇన్ ద ప్రీవియస్ సెషన్. అంటే ఎల్ఈడి అంటే ఏంది, ఫండమెంటల్స్ ఆఫ్ ఎల్ఈడి అంటే ఏంది, నెక్స్ట్ లైట్ ఎమిటింగ్ డయోడ్ అడ్వాంటేజెస్ ఏంది, అప్లికేషన్స్ ఏంది, న్యూమరికల్స్ ఏంది, ఇవన్నీ ఫినిష్ చేసాం కదా. ఓకే, ఆబ్జెక్టివ్స్ ఆఫ్ ద స్పెషల్ పర్పస్ ఎలక్ట్రానిక్ డివైస్ అంటే ఏదో చేసాం కదా. సిమిలర్లీ మనము వీఆర్ గోయింగ్ ఫర్ ద వెరీ వెరీ ఇంపార్టెంట్ కాన్సెప్ట్, అండ్ దట్ పర్టికులర్ వన్ ఈస్ కాల్డ్ లేజర్ డయోడ్స్. ఓకే, ఈ లేజర్ డయోడ్ అంటే ఏంది, ఇది కూడా మనం అన్నీ కంప్లీట్ చేసాం. సో ఇవాల్టి సెషన్, మై డియర్ స్టూడెంట్స్, వీఆర్ గోయింగ్ ఫర్ ద వెరీ వెరీ ఇంపార్టెంట్ సెషన్, అండ్ దట్ వన్ ఈస్ కాల్డ్ semiconductor photoelectric transducers. Okay, semiconductor photoelectric transducers, my dear students. Okay, what is semiconductor photoelectric transducers? Just I am going to depict you in this particular session in a detailed manner, my dear students. Okay, what is this one? Okay, now this is a semiconductor photoelectric transducer. This is semiconductor photoelectric transducer, my dear friends. What does it will do? ఇది ఏం చేస్తుంది? What it performs, my dear students, means semiconductor photoelectric transducer, my dear friends, generally it converts the light energy, means whatever the light you are going to focus on this particular one. Okay, this is photo, my dear friends. It is converting, this is light, this is semiconductor, this is light, and See, this means semiconductor photoelectric transducer means that this semiconductor is converting the light into the output will be in the form of electric signals. Okay, in the form of the electrical signals. In the form of what, my dear students? Electrical signals, my dear students. Okay, in the form of what? Electrical signals. Okay, now this is what over here means here. See, whatever the radiation that is falling on this particular semiconductor. Okay, whatever the radiation that is falling on this particular semiconductor, whether it will be light or it is a optical radiation, okay, or you can take the X-rays or any semi certain corpuscular radiations, okay, whether it will light or X-rays or any, so there is a corpuscular radiations that is falling on this semiconductor. Okay, then these transducer, what is the function of the transducer? Transducer means converting the one form of energy into another form of energy. See here, the transducer is converting this light, my dear students, into what, my dear students? Into electrical signals. Okay, it is converting the light, my dear students, into electrical signals. Okay, it is converting the light into electrical signals, my dear students. Okay, the very important point you need to remember over here. Okay, it is converting in this one. So the here what happens whenever this particular light, okay, is going to be, okay, falling on this particular semiconductor, the process of, okay, energy means here what happens, this semiconductor, okay, here what happens, it absorbs the energy, means the process of energy absorption produces. So what happens, the light is absorbed by this particular semiconductor. Okay, so what happens, the light is absorbed by this particular semiconductor, and then what happens, because of the absorption of the light, okay, because of the this particular absorption of the light, my dear friends, then it produces the movable charges or the change in the mobility of the charge carriers. Okay, then what happens, there is a mobility in the charge carriers. What is present in this one? Holes and electrons means that are present in the semiconductors, and there will be the mobilities in these particular charge carriers, my dears. Okay, so when the light is passing on this particular semiconductor and light is absorbed means by the semiconductor, and that creates that is movable charge carriers, and that charge carriers makes the current that is flowing through the conductor, thereby producing the following effects at the output. Okay, then what happens because of the absorption of this light, my dear friends, producing the following effects. Okay, depending on the type of the transducers. Okay, whatever the type of transducers you are going to use over here, you are going to get the different types of effects. Okay, you are going to get the different types of the effects, my dear friends. Okay, so here what happens, depending on the type of the transducers that you are going to use, okay, over here using the semiconductor, there will be different types of effects that are going to be taking place, my dear students. Okay, what kind of effects, okay, that is also going to be taking place. Let me depict you in a detailed manner. Okay, now depending on the type of the transducers used, depending on the type of transducers used, my dear students, means అంటే ఈ యొక్క సెమీకండక్టర్ని నేను డిఫరెంట్ ట్రాన్స్డ్యూసర్స్ తోని ఒకవేళ నేను ఐఎమ్ గోయింగ్ టు మేక్ ఇట్, మై డియర్ ఫ్రెండ్స్, అంటే ఇక్కడ లైట్ పడడం వల్లే అవుట్పుట్లో ఏమేమి చేంజెస్ ఉంటాయి. ఓకే, దేర్ విల్ బి ఏ చేంజ్, మై డియర్ ఫ్రెండ్స్, దేర్ విల్ బి డిఫరెంట్ ట్రాన్స్డ్యూసర్స్, దేర్ విల్ బి ఏ చేంజ్ ఇన్ ద రెసిస్టెన్స్, and there will be a change in the current, and there will be a change in the voltage, my dear students. Okay, so that's what I'm going to tell you over here. Okay, there will be, what I'm going to tell you itself is change in resistance, which is equal to delta R, my dear friends. There will be, okay, change in current output, current output, my dear friends, and there will be a change in the voltage output. Change in the voltage output, my dear friends. Okay, well, my dear friends, here, okay, ultimately what I am going to tell you itself is that very important parameters means when the light is falling on this particular semiconductor, then the semiconductor, this is a transducer. It is made up of a transducer. It is converting the light into electrical energy. Okay, that okay, depending on the different types of transducers we are going to made with the semiconductor, there are different outputs, like there is a change in the resistance, there is a change in the current, and there is a change in the voltage, my dear friends. Okay, there is a change in the voltage, my dear friends. Okay, very important, you need to remember over here, my dear friends, over here. Similarly, this is about the semiconductor photoelectric transducers. Okay, now in this particular session we are going to study about the different types of the semiconductor photoelectric transducers, my dear friends. Okay, in that the first one is LDR, means light dependent resistor. Second one itself is very important, is okay, PN photodiode. Third one is PIN photodiode. Fourth one is avalanche photodiode. It is called avalanche photodiode, my dear friends. Okay, this is the outputs that you are going to get, my dear friends, over here. Okay, that is at the output. Okay, now see here what ultimately I am going to explain the one by one. Okay, the photodiode in a detailed manner as far as the gate and engineering service are concerned. Not only at that particular point, it is very important, my dear friends. Okay, at the okay, the important parameters just I am going to bring it to you. Okay, at where? Okay, at the academics also, my dear friends. Okay, similarly, now I am going for the first one, and the first one itself is, I told you, is very important. And what is that one? LDR, light dependent resistor. The other name is also called photoresistor, or it is also called photoconductive cells, or it is also called photoconductors. It is also called photoconductors, my dear students. Okay, LDR means light dependent resistor, or it is also called photoresistor, or it is also called photoconductor, or it is also called photoconductive cells, my dear students. Okay, generally what happens at the receiver, at the optical receiver, if you are going to take any particular receiver, so at the receiver, okay, what happens, this is a, all these are all the receivers, my dear students. Okay, what happens over here, if I am going to take any receiver, here what is traveling, light is traveling inside. Okay, this light, this particular optical receiver is converting the output into electrical signals. It is converting into the electrical signals, my dear students. Okay, it is converting. So here what happens, in any optical fiber, okay, it is required to convert these particular optical signals, here the receiver, back into the electrical signals, my dear students. Okay, so here what happens, this task is normally performed by what? This task is normally performed by the optical, that is detector, optical detector, my dear students. Okay, the overall system performance is governed by this particular optical detector only. Okay, by this optical detector only, and these optical detectors are available in different shapes. Okay, that is, first one itself is that is LDR, second one is PN photodiode, third one is PIN photodiode, and fourth one is avalanche photodiode. Okay, we are going to study all these particular, okay, the electronic photodiodes and their respective properties and the problems that has been asked in the previous papers, my dear students. Okay, similarly, okay, the designer requirements of these particular, okay, these particular optical detectors are same as optical sources. Okay, what we have finished in the previous class, మనం నిన్నే చూసాం నాన్న, ఆప్టికల్ సోర్స్ అంటే ఎల్ఈడీస్ లేజర్స్ గురించి చదివాము. ఇలానే ఆప్టికల్ డిటెక్టర్స్ అంటే సోర్స్ ఏం చేస్తుంది, లైట్ ని జనరేట్ చేస్తుంది. ఓకే, దాన్ని డిటెక్ట్ చేయడానికి ఆప్టికల్ డిటెక్టర్. ఓకే, ఇప్పుడు ఇవాళ సెషన్ మొత్తం మనం ఏం చేస్తున్నాము, వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ దీస్ పర్టికులర్ ఆప్టికల్ డిటెక్టర్స్, మై డియర్ స్టూడెంట్స్. ఓకే, అబౌట్ దీస్ పర్టికులర్ ఆప్టికల్ detectors, my dear students. Okay, and see here, what are the detectors? Okay, we are going to study in today's session. And what are the detectors we have been designed, my dear friends? Those detectors are having the high sensitivity, my dear friends, and we are operating at the good wavelengths, okay? And high sensitivity, not only at the high sensitivity, my dear friends, it is having a very good response. It is going to give these optical detectors and high fidelity. The output is in a very good manner and high reliability. And whatever the detector I have been designed, okay, that will work for the longer periods of time, my dear friends, okay, that will work for the longer periods of time, my dear friends. Very very important one, okay, over here. And similarly, one more important thing, okay, whatever the optical detector we have been designed, my dear friends, that will be having a low noise and low cost, my dear friends. That will be having a low noise and a low cost, okay. And further, always we should be comparable with the core, because the main role is played by the core of this particular optical fiber, okay. That's the reason the core is very very important. So once again, ఒకే పారామీటర్ లో నేను చెప్పాల్సుకుంది ఏమనుకుంటా అంటే, మనం ఏదైనా కూడా ఆప్టికల్ డిటెక్టర్ ఏం చేస్తుందంటే, ఇట్ ఈస్ కన్వర్టింగ్ ద లైట్ ఇంటూ ఎలక్ట్రికల్ సిగ్నల్స్, ఓకే. సెకండ్ థింగ్, ఏదైనా ఆప్టికల్ డిజైనర్ మన ఆప్టికల్ డిటెక్టర్ డిజైన్ చేసేటప్పుడు డెఫినెట్లీ దానికి పారామీటర్స్ ఏమి ఉండాలంటే, హై సెన్సిటివిటీ ఉండాలి, మై డియర్ స్టూడెంట్స్, హై ఫిడిలిటీ ఉండాలి, and my dear students, it will work for a longer periods of time, my dear students, and moreover low noise it will be taken into account, okay. And these requirements are easily met by the detectors, my dear friends. What are the parameters I told you when it is manufactured with the semiconductors? When, my dear friends, when it is manufactured with the semiconductor materials, okay. That's the reason in today's class we are going for the what kind of detection principle are used, okay, in the semiconductor photoelectric transducers, my dear friends, and what kind of the design that can be used in such detectors, just I am going to explain in a detailed manner, okay. In that, the first parameter itself is called LDR itself is called the light dependent resistor, my dear friends, okay, which is called the light dependent resistor, my dear friends, okay. So here the first point itself is very very important, okay. So first point itself is that whatever the general requirements of any optical detector, what are the general requirements, my dear friends? High sensitivity, my dear students. Similarly, okay, operating at good wavelengths, high fidelity, next one, my dear friends, fast response, next one itself is very very important, my dear friends. Fast response is there, high reliability, my dear friends, and low noise, and it is low cost. And low cost, my dear students, okay. These are all the important parameters, just I would like to bring it to your notice, my dear friends, okay. But whatever the optical detectors, that is all these particular parameters are very very important. But these parameters you can achieve, my dear friends, when you are going to when we are going to design the optical detector with what, my dear friends, with the semiconductor material. With semiconductor materials, my dear friends, okay, with semiconductor materials, okay. So in this particular section we are going to study one by one what is the detection principle, on what principle, my dear friends, the LDR or the photo resistors or the photoconductor works, my dear friends, and what is the design of these particular such detectors. Let me depict you in a detailed manner, my dear friends, in this particular session in a detailed manner over here, okay. So can we start, my dear friends, over this particular session, okay. Similarly, Okay. Similarly, now these are all the general parameters. Just I would like to bring it to you before entering into the subject, my dear students. Okay. Similarly, now I am going to the first one. What is the first one? Light dependent resistor or photoresistor or photoconductor, my dear students. Okay. Light dependent resistor or photoresistor or photoconductor, my dear students. Okay. On which principle it depends? Okay. It depends upon what, my dear friends? It depends upon the principle of what? It depends upon the principle of the photoconductivity. Okay. It depends upon the principle of what, my dear friends? Photoconductivity. So here ultimately the LDR, light dependent resistor, or whatever the photoresistor, my dear friends, on which principle it is working means it is working on the principle of photoconductivity. Principle of principle of what, my dear students? Photoconductivity. It works on the principle of what? Photoconductivity, my dear students. Okay. And see here, now light dependent resistors. What is the meaning of these light dependent resistors? Okay. Light dependent resistors are simply means the resistivity is changing, my dear students, as a function of the incident electromagnetic radiation. Means when I'm protecting, okay, when you are protecting the light on this is a what, my dear students? I'm going to take it any LDR. Okay, any LDR, my dear students, when I am protecting the light is nothing but electromagnetic wave. Okay, so when I am protecting the light on this particular LDR, then what happens? The light dependent resistor. Then what happens? Here, what happens? The resistivity changes. The resistivity is changes, my dear students. Okay, the resistance changes, my dear students. Then what happens? Here, what I am going to tell you itself is that LDR, light dependent resistor, is a photo. Okay, it is a device, my dear students, whose resistance is a function of what, my dear students? Is a function of the electromagnetic radiation which is incident. Okay, is a function of the electromagnetic radiation, my dear students, which is going to be incident over there, my dear students. Okay, so on this one. Okay, that's the reason LDRs, light dependent resistors, are also called as light sensitive devices. Okay, light sensitive devices, my dear students. Okay, that's the reason these are also called photoconductors or photoconductive cells, my dear students. Okay. Okay. And these light dependent resistors is always made up of, I told you what type of materials? Semiconductor materials. It is made up of the semiconductor materials having high resistance. Okay, having always the resistance should be high, my dear. So it's okay, very very important point. You need to remember always these. Okay, these are made up of the semiconductor materials having the high resistance. Okay, there are different symbols that we are going to be indicate these light dependent resistors, that I am going to tell you when the subject progresses, my dear students. Okay, see here, but the most commonly used, okay, the most commonly used itself is that this is like this, my dear students. Maximum, this is a light dependent resistor. Maximum, maximum it will be like this. So a light is projecting, the light is projecting, my dear students, on this particular one. Okay, the light is projecting on this particular one, my dear students. Okay, very very important on this particular one over there. Then automatically what happens? See here. Okay, the resistance means here these are made up of the semiconductor materials always having the high resistance, my dear students. Okay, and I told you that always the light dependent resistors are depending on what? On the principle of the photoconductivity, my dear students. Okay, now what is the photoconductivity? Okay, let me depict you, my dear students, in a detailed manner over here in the next paper, my dear students. Okay, very very important one. Okay, now what is photoconductivity? Okay, listen carefully, my dear students. A light dependent resistor always depends on what, my dear friends? Photoconductivity. It works on the principle of the photoconductivity. Photoconductivity, what is this one? Photoconductivity is nothing but a optical phenomena. It is nothing but a optical phenomena. What happens, my dear students? The material resistivity reduces. Means, suppose here what happens? Here, if I am going to take, this is a light dependent resistor. This is a light dependent resistor, my dear friends. If I am projecting the light on this one, if I am projecting the light on this particular one, what happens, my dear friends? As a result of that, the resistivity reduces. Okay, means here what happens? Generally, this is having the more resistance initially. The resistance is more initially. But what happens, my dear friends? When the light is projecting on this one, more amount of the light is absorbed. So when the more amount of the light is absorbed here, automatically the resistance reduces. The resistance is reduces because of the light is absorbed by this particular LDR, light dependent resistor, my dear friends. Okay, that is the one more important thing that you need to remember over here, my dear friends. Okay, another important point you need to remember. What happens, my dear friends? Okay, this is made up of what? Semiconductor material. So what happens if the light is falling on this semiconductor? Okay, when the light falls on this particular semiconductor, when the light is falling on this particular semiconductor, my dear friends, what happens, my dear friends? Okay, when the light, okay, is falling, when the light means nothing but the photon, okay, is falling, my dear friends, on this particular semiconductor. The semiconductor is having this particular band, my dear friends. Then what happens? The electrons in the valence band, okay, what are the electrons in the valence band that will jump to the here? Conduction band. Okay, electrons in the valence band can jump to the conduction band. Okay, this is valence band, this is conduction band, my dear friends. Okay, then the electrons in the valence band of the semiconductor, this is the electrons in the valence band, my dear friends, of the semiconductor are excited to the conduction band, my dear friends. Okay, the photons, my dear friends, in the incident light, okay, what are the energy of this particular photon? Okay, energy of the photon, my dear friends, is always, okay, is always greater. This is the energy gap of this one. Okay, the photon is always the greater or equal to the energy gap of the semiconductor. Then only what happens, my dear friends? Here, okay, here what happens? Here the electrons jump from the valence band to the conduction band. Okay, when the light falling of energy is incident on this device, then what happens? More and more electrons are jumping from here to here. More number of electrons are jumping from here to here. Okay, from here to here it is jumping, my dear friends. Okay, like that. Then what happens? So ultimately what happens, my dear friends? See, more and more. Okay, then which results in the large number of carriers. Okay, ఏమైతుంది ఇక్కడ large number of carriers వస్తాయి. Ultimately here what you are getting? Large number of charge carriers. Large number of charge carriers, my dear friends. Large number of the charge carriers are present over here, my dear friends. Okay, as a result of that, this process, more and more number of, okay, current flows because of the electrons are jumping from the valence band to the conduction band, my dear friends. Okay, then what happens in this particular process? The resistance of the device is reducing. Okay, the resistance of this particular device is going to be reducing. Okay, then what happens, my dear friends? The resistance of this particular device has been decreased, and this is the working principle of LDR. Okay, and this is nothing but the working principle of what, my dear friends? LDR, that is nothing but the light dependent resistor. Okay, so now you got it, my dear friends. And ఏం లేదు నాన్న. Okay, ఎప్పుడైతే ఈ లైట్ అనేది ఓకే ఈ యొక్క సెమీకండక్టర్ ఓకే ఈ యొక్క ఎల్డిఆర్ మీద పడితే ఓకే అప్పుడు ఏమవుతుంది, రెసిస్టెన్స్ తగ్గుతుంది. ఎలా తగ్గుతుందంటే ఈ లైట్ని అబ్జార్బ్ చేసే వల్ల ఓకే మోర్ అమౌంట్ ఆఫ్ ఎనర్జీ ఈజ్ రిక్వైర్డ్. ఓకే సో ఎనర్జీ ఎక్కువ తీసుకుంటుంది కాబట్టి రెసిస్టెన్స్ తగ్గింది. ఓకే ఇంకోటి ఉంది, దీని యొక్క క్రిస్టల్ ఎలా ఉంటుందంటే మీకు ఎప్పుడైతే ఈ లైట్ అనేది పడడం వల్ల ఏమవుతుందంటే ఇక్కడ ఉండే ఎలక్ట్రాన్స్ అన్ని కండక్షన్ బ్యాండ్కి వెళ్ళిపోతాయి. ఓకే సో వెళ్తాయి. ఇలా ఎందుకు వెళ్తాయంటే ఇది వెళ్ళడానికి కూడా కారణం ఏంటంటే ఎప్పుడు ఎనర్జీ ఆఫ్ ద వాట్ ఎవర్ ద లైట్ యూ హ్యాడ్ గివెన్ షుడ్ బి గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు ఎనర్జీ గ్యాప్ ఆఫ్ ద సెమీ కండక్టర్ ఉంటేనే ఇక్కడ మోర్ అండ్ మోర్ చార్జ్ క్యారియర్స్ అనేవి ఉంటాయి. దానివల్ల ఏమైంది నానా, అల్టిమేట్లీ వాట్ హ్యాపెన్స్ my dear friends, the conductivity increases. Okay conductivity increases. conductivity పెరిగిందంటే ఏంటన్నా కరెంట్ V ఈక్వల్ టు IR కదా. ఓకే కరెంట్ పెరిగిందంటే దాని అర్థం ఏంది, కరెంట్ పెరిగిందంటే రెసిస్టెన్స్ ఆఫ్ ద డివైస్ తగ్గినట్టే. the resistance of the device is going to be decreasing my dear friends. Okay the resistance of the device is going to be decreasing my dear friends. Okay very very important point you need to remember over here my dear friends. Okay is that clear up to here everyone? Is that clear up to here everyone? Okay similarly this is the main principle involved my dear friends where in the what LDR, that is light dependent resistor my dear friends. Okay అందుకే ఇక్కడ ఏమైతుంది, నీకు లైట్ ఉండడం వల్ల ఏమవుతుందన్నా, ఇక్కడ నేను ఏం చేస్తున్నాను, లైట్ ఉండడం వల్ల ఓకే లైట్ అనేది దీన్ని ప్రొజెక్ట్ చేయడం వల్లనే నీకు రెసిస్టెన్స్ అనేది తగ్గుతుంది. అంటే ఇక్కడ నేను లైట్ ఉండడం వల్ల నీకు లైట్ పెట్టడం వల్ల మై డియర్ ఫ్రెండ్స్ ప్రొజెక్ట్ చేయడం వల్ల రెసిస్టెన్స్ తగ్గుతుంది. ఓకే నేను రెసిస్టెన్స్ని పెంచాలనుకుంటున్నా. ఓకే నేను ఐ వాంట్ టు ఇంక్రీజ్ ద రెసిస్టెన్స్ అంటే ఏం చేస్తానంటే ఈ యొక్క ఎల్డిఆర్ని, ఈ లైట్ డిపెండెంట్ రెసిస్టర్ని నేను లైట్ లేని రీజియన్ నుంచి లైట్ ఉన్న రీజియన్ నుంచి లైట్ లేని రీజియన్ తీసుకెళ్తా. ఐ విల్ షిఫ్ట్ దీస్ ఎల్డిఆర్ ఫ్రమ్ ద లైట్ రీజియన్ టు ద నో లైట్ రీజియన్. ఓకే అంటే ఈ లైట్ లేని రీజియన్ తీసుకెళ్తాను వేర్ దెర్ ఇస్ నో light my dear students. Okay light in region in this keltam. Okay then what happens my dear students, the resistance of the device is going to be decreasing. Then what happens my dear students, the resistance of the device is going to be increasing my dear students. అంటే లైట్ ఉండడం వల్ల రెసిస్టెన్స్ తగ్గింది అంటే నేను లైట్ లేని రీజన్ కంటే అండ్ మీన్స్ ఎక్కడైతే నీకు రెసిస్టెన్స్ అనేది పెరిగిందో the thing might where the very light means I taking a light dependent resistor in the dark region, then what happens, dark region means where there is no light and the resistance offered in the darkness, and that resistance is called dark resistance. A resistance ఏమంటాం నాన్న, dark resistance అంటాం. We are going to call it as a dark resistance my dear students. Okay this is what I am going to tell you my dear students over here. Here some important parameters just I would like to bring it to your notice. Okay what is that? Okay already once again summary is that the light dependent resistor always my dear students works upon the principle of photoconductivity. Photoconductivity means I told you that it is a optical phenomena in which the material resistances are reducing when the light is projecting on this LDR, because when the light is projecting on this particular one, what happens, more amount of the light is more amount of the energy is taken in absorbing, then resistance is decreasing. So what kind of conclusions I have drawn in this generally in the working principle of LDR, very very important working principle of LDR. Working principle of LDR. Okay the important parameters you have to remember my dear friends. If incident light intensity increases, when the incident light that is intensity increases my dear friends, then what happens, that is increased the free electrons. Okay then more charge carriers, more, then what happens, conductivity is more, is more, my dear friends, and the resistance, my dear friends, is equal to low. Okay, then what happens, the next parameter is that if the incident light intensity decreases, then charge carriers low, my dear friends, then conductivity is also low. Then what happens, the resistance increases. Okay, then what happens, the resistance means the offered, my dear friends, in darkness, because here the resistance is increasing, my dear friends, when there is no light intensity, and that particular resistance is called what, my dear friends, dark resistance. And what is that value, my dear friends? That particular value itself is very important, that I am going to tell you the characteristics. Okay, this is the working principle, my dear friends, and general parameters. Just I would like to bring it to your notice over here, my dear friends, when comes into the, that is light dependent resistor. Now I am going for the construction, my dear friends. LDR construction, my dear friends. Okay, so how the LDR is there? First we have to see the complete construction, very very important at part the gate and engineering services level. How it will be there. This is what this is LDR, light dependent resistor. See here, I am going to take this one is a leads. Inside how it will be there. Leads, my dear friends. This is, see here, ceramic substrate. Ceramic substrate, my dear friends. Okay, and see here the photoconductive layer coated on the ceramic substrate. See here, photoconductive layer. This is the photoconductive layer coated on ceramic substrate, my dear friends. Okay, so the photoconductive layer that we are going to coat on this particular ceramic substrate, my dear friends, and internally, so after this we are going to take it the ceramic substrate, then coat with this one photoconductive layer on this one, then place the electrodes on this one, placing of these electrodes, placing of these particular electrodes, my dear friends. These are the electrodes that has been placed inside this one, my dear friends. Very very important. The construction itself is similarly, and the process of keeping these electrodes and closing, my dear friends. Okay, and this process is called encapsulation. Encapsulation, my dear friends, electrodes. Okay, it is made up of gold, my dear friends. Gold, my dear friends. Okay, so here ultimately what happens, we are keeping these particular electrodes, my dear friends, internally LDR. So here this is placed completely in a photoconductive layer. Okay, and after this one, this photoconductive layer is pasted on this ceramic substrate, my dear friends. Okay, here the very important thing itself is that what is the photoconductive layer is made up of. Okay, the photoconductive layer is very important, my dear friends. And what kind of pattern of the deposition of electrodes, all these are the various questions. Okay, the electrodes deposition emantar nana. Okay, very important. Okay, the pattern of, that is deposition of these electrodes. Okay, ee pattern emantar adigaru. Okay, ela unnai nana, ఈ ప్యాటర్న్ ఎలా ఉన్నాయి, ద ప్యాటర్న్ ఆఫ్ డిపాజిషన్ ఆఫ్ దీస్ ఎలక్ట్రోడ్స్ ఈజ్ కాల్డ్, ఈ ప్యాటర్న్ కోంబ్ ప్యాటర్న్. మన దువ్వెన ఎలా ఉంటుంది, కోంబ్ ప్యాటర్న్. రెండు దువ్వెనల అంటే రెండు దువ్వెనలు, మై డియర్ స్టూడెంట్స్, రెండు దువ్వెనలు ఇలా వీఆర్ హ్యావింగ్ ద ఇలా ఉంటాయి, కోంబ్ ప్యాటర్న్. ఓకే, కోంబ్ ప్యాటర్న్ అనొచ్చు దీన్నే. దీనికి ఇంకో పేరు ఇంటర్లాక్ ప్యాటర్న్ అనొచ్చు. దీనికి ఇంకో పేరు జిగ్ జాగ్ ప్యాటర్న్ అని అనొచ్చు. జిగ్ జాగ్ ప్యాటర్న్ అని కూడా వీఆర్ గోయింగ్ టు డిస్కస్, మై డియర్ స్టూడెంట్స్. ఓకే, ఇలా కూడా అనొచ్చు. ఓకే, ఇది ఎల్డిఆర్ కన్స్ట్రక్షన్లో వెరీ ఇంపార్టెంట్, మై డియర్ స్టూడెంట్స్. ఓకే, నా ఇక్కడ ఈ ఫోటో కండక్టివ్ లేయర్ దేంతో చార్జ్ చేస్తారు, ఇది కూడా వెరీ ఇంపార్టెంట్, మై డియర్ స్టూడెంట్స్. దాస్ ఐఎమ్ గోయింగ్ టు డిపిక్ట్ ఇన్ ద నెక్స్ట్ పేజ్. దేంతో తయారు చేస్తారు. ఓకే, ఫోటో కండక్టివ్ లేయర్ ఈజ్ మేడ్ అప్ ఆఫ్ మెటీరియల్స్. మెటీరియల్స్ used for the photoconductive layers. It is made up of cadmium sulfide CDS. Or you can design with cadmium selenide. Cadmium selenide, my dear friends, or lead sulfide. Lead sulfide, my dear friends. Lead selenide. Lead selenide or lead telluride, PBTE. Lead telluride, my dear students. Okay, generally we are going to use these particular materials. ఈ ఫస్ట్ రెండు మెటీరియల్స్ బాగా వాడతాం నాన్న, which is made up of, my dear students, LDR. Okay, so the energy gap ఎంత దీన్ని అడిగాడు cadmium selenide ఇంత ముందు. The energy gap is very important. This is 2.42 electron volts. Okay, this one is the energy gap ఎంత అడిగాడు, 1.74 electron volts, my dear students. Okay, ఈ రెండు వాడు మనకి వాడండి అన్న. జనరల్లీ వీఆర్ గోయింగ్ టు యూజ్ దిస్ పర్టికులర్ వన్, మై డియర్ స్టూడెంట్స్. ఓకే, సో ఇవన్నీ డిఫరెంట్. ఓకే, మనము వాడతాం, జనరల్గా మనం వాడే మాత్రం ఇవే. ఓకే, ఇది ఎల్డిఆర్ కన్స్ట్రక్షన్, మై డియర్ స్టూడెంట్స్. ఓకే, హౌ వీఆర్ గోయింగ్ టు యూజ్ ద ఎల్డిఆర్, మై డియర్ స్టూడెంట్స్, వాట్ ఆర్ ద పారామీటర్స్. ఓకే, సో దీస్ ఆర్ ద వేరియస్ ఇంపార్టెంట్ పారామీటర్స్ that you need to remember over here. Now next one is the LDR characteristics. Okay, when you are going to take the characteristics of the LDR, see here, LDR characteristics. This is what LDR characteristics. See, it is resistance in ohms. Y-axis indicates resistance in ohms. Okay, that is 10. It is increasing 10 to 10 power, my dear friends, 8. And here it is light. Illumination. Units are light is lux. Illumination. Illumination, my dear friends. Lumens. LUX, my dear friends. Generally, I am going to take it the 3 parameters. ఇక్కడ చూడండి అన్న, నేను 3 చోట్ల తీసుకుంటున్నాను లైట్. ఇదేమో డార్క్ రీజియన్లో, మై డియర్ ఫ్రెండ్స్. ఇది డే సన్, ఇది డే లైట్. థర్డ్ వన్ ప్యూర్ సన్ లైట్లో పెట్టినప్పుడు ఎల్డిఆర్ని, మై డియర్ ఫ్రెండ్స్. ఓకే, అంటే అల్టిమేట్లీ వాట్ హ్యాపెన్స్, మై డియర్ ఫ్రెండ్స్, నేను ఏం చెప్పాను, డార్క్ రీజియన్లో ఏం చెప్పాను, రెసిస్టెన్స్ పెరుగుతుంది. రెసిస్టెన్స్ కరువు కదా, అంటే మీరు రెసిస్టెన్స్ అనేది పెరుగుద్ది. ఓకే, సిమిలర్లీ నెక్స్ట్ డే లైట్లోకి వచ్చేసరికి రెసిస్టెన్స్ అనేది కొద్దిగా తగ్గుద్ది. సన్లైట్లోకి వచ్చేసరికి మొత్తం కాబట్టి చాలా తక్కువ ఉంటుంది అన్న. అంటే ఇక్కడ లైట్ మీద ప్రొజెక్ట్ చేస్తే ఎక్కువ లైట్ పెడితే రెసిస్టెన్స్ అనేది తక్కువ. ఇక్కడ డే లైట్లో పెట్టేసరికి సన్లైట్ కాబట్టి మై డియర్ ఫ్రెండ్స్ చాలా తక్కువ. ఇంకొద్ది డే లైట్లో కాబట్టి దీనికంటే కంపారిటివ్ ఇది లైట్ ఓకే కొద్దిగా ఎక్కువ కాబట్టి మై డియర్ ఫ్రెండ్స్ రెసిస్టెన్స్ కొద్దిగా. ఇక్కడ కంప్లీట్గా డార్క్ రీజన్ తీసుకొచ్చాను మై డియర్ ఫ్రెండ్స్. డార్క్ రీజన్లో ఏమైతే రెసిస్టెన్స్ అనేది ఎక్కువ ఉంటుంది అన్న, my dear friends. Okay, these are the characteristics. Just I would like to bring it to your notice, my dear friends, when it comes into the photodiodes. Okay, is that crystal clear, my dear friends, up to here, everyone? Okay, is that clear, my dear friends, up to here, everyone? Okay, similarly now ఇప్పుడు ఏమవుతుంది అంటే మీకు ఇంపార్టెంట్ పాయింట్ చెప్తాను ఇక్కడ. ఓకే, ఎల్డిఆర్ క్యారెక్టరిస్టిక్స్ నా ఇక్కడ క్యారెక్టరిస్టిక్స్లో ఒక ఇంపార్టెంట్ పాయింట్ చెప్తాను. ఇది ఒక ఎల్డిఆర్ తీసుకోండి. ఎల్డిఆర్ తీసుకున్న తర్వాత ఇది ఒక లైట్ డిపెండెంట్ రెసిస్టర్. వెన్ ద లైట్ ఈజ్ ఇన్సిడెంట్ ఆన్ ద ఫోటో సెల్, ఈ యొక్క ఫోటో సెల్ మీద లైట్ని ఇన్సిడెంట్ చేస్తే ఏమవుతుందన్నా, ఇట్ యూజువల్లీ టేక్స్ అబౌట్ 8 to 12 milliseconds ఫర్ ద చేంజ్ ఆఫ్ ఇట్స్ రెసిస్టెన్స్. ఓకే, ఏమైంది, ఈ లైట్ పడంగానే మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఈజ్ అబ్జార్బ్డ్. ఓకే, అబ్జార్బ్ అయినప్పుడు రెసిస్టెన్స్ తగ్గుద్ది. ఈ రెసిస్టెన్స్ తగ్గేదానికి ఎంత టైం తీసుకుంటుందంటే 8 to 12 milliseconds తీసుకుంటుంది రెసిస్టెన్స్ తగ్గడానికి. నాన్న okay, it takes about 8 to 12 milliseconds to change its resistance. Okay, again my dear friends, to takes why it takes seconds for the resistance to rise back again to its initial అంటే ఇది అంటే రెసిస్టెన్స్ చేయడం. అదే నేను లైట్ తీసేసిన తర్వాత లైట్ అంటే ఇక్కడ నీకు ఏమవుతుంది 8 to 12 milliseconds తీసుకుంటుంది. అంటే నేను ఒక లైట్ నేను ఒక 10 o'clock పెట్టాను. ఓకే, 10 o'clock ఉన్నప్పుడు లైట్ పెట్టినప్పుడు ఆఫ్టర్ సమ్ టైమ్ ఏమైంది, రెసిస్టెన్స్ తగ్గింది. అంటే 8 to 12 milliseconds తీసుకుంటుంది. అదే ఈ లైట్ని తీసేసా, ఈ లైట్ని తీసేయడం వల్ల మళ్ళీ దాని కరెక్ట్ వాల్యూ రావడానికి చాలా తక్కువ టైం. ఓకే, చాలా తక్కువ టైం టు గెయిన్ బ్యాక్ ఇట్స్ ఇనిషియల్ వాల్యూ. దాన్ని ఏమంటారంటే దిస్ ఈజ్ ఆల్సో ఆఫ్టర్ ద రిమూవల్ ఆఫ్ లైట్ అండ్ దిస్ వన్ ఈజ్ కాల్డ్ రెసిస్టెన్స్ రికవరీ రేట్ అంటారు. ఓకే, దాన్ని ఏమంటారు, రెసిస్టెన్స్ రికవరీ రేట్ అంటారు మై డియర్ స్టూడెంట్స్. ఓకే, వన్స్ అగైన్ ఐఎమ్ గోయింగ్ టు ఎక్స్ప్లెయిన్ ఇన్ యువర్ టెర్మినాలజీ. వెన్ ఎ లైట్ ఈస్ ఇన్సిడెంట్ ఆన్ ఎ ఫోటో సెల్, when a light is going to be incident on this photo cell, it usually takes about 8 to 12 milliseconds, my dear friends, for the change of its resistance. Okay, for the change of its resistance. Okay, and to rise back again to its initial value. Okay, after the removal of the light. Okay, to get back its original value, it takes very less seconds, and this concept is called resistance రికవరీ రేట్ అంటారు. దీని ఏమంటారు? రెసిస్టెన్స్ రికవరీ రేట్ అంటారు. We are going to call it as a resistance recovery rate, my dear students. Okay, very important point. Just I would like to bring it to your notice over here. Okay, these are the general parameters. Just I would like to bring it here. So here LDRs. Okay, LDRs are very less sensitive. Okay, that sensitivity is less than the coming PN photodiodes or photodiodes, my dear students. Okay, these are very less sensitive, my dear students. Okay, very important one. Okay, and the types of LDRs. LDR any types ఉంటాయి, my dear students. Okay, very important. Okay, types of light dependent resistors. How many types of the light dependent resistors are there? Generally, two types of the light dependent resistors are there, my dear friends. One is called intrinsic photo, that is LDRs or photoresistors. Photoresistor na LDR ఒకటే. Intrinsic LDR, my dear friends. Intrinsic means undoped LDR. It is not doped, my dear students. Okay, undoped. Okay, this is undoped LDR, pure form, my dear friends. Okay, and these are the pure semiconductors. So it is made up of the pure semiconductor material like silicon or germanium. It is made up of the pure semiconductor material, my dear students, made up of silicon or germanium. So automatically what happens in these particular crystals, my dear students, the electrons are get excited from the valence band to the conduction band. సో ఇక్కడ ఏమవుతుందనా, ఎలక్ట్రాన్స్ అనేది ఈజీగా ఎగ్జైట్ అయిపోతాయి. ఓకే, ఎలక్ట్రాన్స్ ఆర్ ఈజీలీ ఎగ్జైటెడ్, మై డియర్ ఫ్రెండ్స్, ఫ్రమ్ వ్యాలెన్స్ బ్యాండ్ టు ద కండక్షన్ బ్యాండ్. ఓకే, వ్యాలెన్స్ బ్యాండ్ నుంచి కండక్షన్ బ్యాండ్కి ఈజీగా ఎగ్జైట్ అవుతాయి. దీస్ ఆర్ ఎగ్జైటెడ్ ఈజీలీ, మై డియర్ ఫ్రెండ్స్. Excited easily, my dear students. Okay, valence band నుంచి conduction band ki, my dear students. Okay, very important. Okay, so దాని వల్ల ఏమవుతుంది, say here more number of charge carriers are going to be taking place. సో ఇక్కడ కొద్దిగా ఎనర్జీ ఎక్కువ, ఎందుకంటే ఎనర్జీ గ్యాప్ అనేది చాలా ఎక్కువ కాబట్టి it takes more time, my dear students. Okay, it takes more time. Okay, అదే సెకండ్ వన్కి వచ్చేసరికి extrinsic LDR, or it is called doped, or it is called doped LDR. It is called a doped LDR. What is this doped LDR, my dear students? Okay, doped LDR means these are the semiconductor materials which is extrinsic, means impure form, because we have done the doping on the LDR. Then automatically what happens? Conductivity increases. Then automatically what happens? Conductivity increases, my dear students. Okay, because of the doping of this LDR. Okay, the intrinsic LDR plus doping, it becomes the extrinsic LDR, my dear students. There will be a creation of the new energy bands above the valence band. Okay, inka konni energy bands extra create అవుతాయి above the valence band ikkada. Okay, some more energy bands are going to be created above the valence band. Then what happens, my dear friends? Here what happens? Ultimately what happens, my dear students? Ultimately the parameters that has been changed over here, because the energy gap is decreasing over here, my dear students. Okay, whenever the energy gap is decreasing over here, okay, then automatically then energy gap is decreasing over here, my dear students. Okay, whenever the energy gap is decreasing over here, then what happens, my dear friends? Okay, the less energy is required in exciting or moving the electrons from the valence band to the conduction band, my dear friends. Okay, less energy is required over here. Okay, no need of going for the much more energy, no need of going for the much more energy over here, my dear friends. Okay, the less amount of the energy is required over here, my dear friends. Okay, is that clear? Okay, the amount of the energy itself is taken is very less, my dear friends. Okay, similarly is taking is a very less over here, my dear students. Okay, very important point you need to remember over here, my dear students. Okay, so that's the reason I am going to depict you over here is a this particular one. Okay, అంటే ఇక్కడ దీని వల్ల ఏమవుతుందంటే ఎనర్జీ గ్యాప్ తక్కువ ఉండడం వల్ల టైం అనేది తక్కువ, అందుకే దీనిలో కండక్టివిటీ అనేది ఫాస్ట్గా ఉంటుంది దీంతో పోలిస్తే. ఎందుకంటే ఇక్కడ వేరే ఎనర్జీ బ్యాండ్స్ క్రియేట్ అయినాయి కాబట్టి ఎనర్జీ గ్యాప్ అనేది చాలా తక్కువ. Okay, so that's the reason these extrinsic doped, okay, LDRs or the photoresistors are generally used for long wavelengths. Okay, ekkada use them? Used for long wavelengths. Okay, generally we are going to use, where my dear students, we are going to use for the long wavelengths, my dear students. Okay, we are going to use it for the long wavelengths, means generally the parameters are going to be changing over here. Okay, long wavelengths, my dear students. So this is the another important point you need to remember over here, my dear students. Okay, similarly, okay, this is about the extrinsic LDR, my dear students. Okay, similarly, wait a minute. So this is about this particular point over here, my dear students. Okay, so this is used for the long wavelengths, my dear students. Okay, similarly, okay, this is about this particular parameter over here, my dear students. Okay, similarly, now I am going for the, this is about the extrinsic doped LDRs, my dear students. Okay, this is about the types of LDRs over here. Okay, similarly, the applications where we are going to use these particular LDRs also very important. Okay, first, before going for the applications, the first characteristic is dark resistance. What is dark resistance? The resistance offered by the photoresistor when placed in darkness. Offered by the photoresistor when placed in darkness and that one is called dark resistance. And what is the value of that particular dark resistance? How much, my dear friends? Very, very important. 1012 ohms. 1012 ohms, my dear friends. Okay. Similarly, what is the sensitivity? Sensitivity of the photoresistor. Now, sensitivity. The sensitivity itself is that, my dear friends, what I am going to do on LED or LDR. If I am going to take this is LDR. See here, ultimately delta R by delta H, my dear friends. Okay, delta R is the change in resistance to the change in the irradiation. Okay, change in resistance means here what happens? I'm keeping this light. Okay, the light that is coming out from any particular one is called irradiance. That is delta H, and this one is changing. The resistance is changing, my dear friends. Okay, then it will be delta R by delta H, my dear friends. Okay, delta R by delta H means the change in resistance by change in illumination. Change in resistance divided by the change in illumination, my dear friends. Okay, so this is what the sensitivity. Okay, the sensitivity. So what ultimately I am going to tell you itself is that means I am going to project అంటే ఇది irradiance అన్నమాట. Delta H అంటే irradiance అంటే the light that is coming out. ఓకే, ఈ చేంజ్ అనేది దేని చేంజ్ అవుతుంది? రెసిస్టెన్స్ చేంజ్ అవుతుంది. ఓకే, దిస్ ఈస్ ద సెన్సిటివిటీ ఆఫ్ ద ఫోటో రెసిస్టర్, మై డియర్ ఫ్రెండ్స్. ఓకే, అండ్ ద యూనిట్స్ ఫర్ ద sensitivity of the photoresistor resistance is ohms, my dear friends, divided by irradiance. Irradiance, my dear friends, simply we are going to call it as a intensity. Okay, what is the units of intensity? Intensity is equal to power by area. Power by area, my dear friends. Okay, power by area means the power itself I am going to call it as watts, and the intensity area is meter square. So units are ohm, meter square, my dear friends, per watts, my dear friends. Okay, ohm meter square per watts, my dear friends. Okay, this is what అంటే ఇక్కడ ఏమైతుంది, దీన్ని నేను లైట్ ఇస్తున్నాను, చేంజ్ రెసిస్టెన్స్ అండ్ అవుట్పుట్ అండ్ సెన్సిటివిటీ అంటే అవుట్పుట్ బై ఇన్పుట్. ఇది అవుట్పుట్ కదా, ఇది ఇన్పుట్ కదా, మై డియర్ ఫ్రెండ్స్. ఓకే, దెన్ ఇట్ ఈస్ వాట్ యు ఆర్ గెటింగ్ ఓవర్ హియర్, మై డియర్ ఫ్రెండ్స్, ఈస్ దిస్ పర్టికులర్ వన్. ఓకే, దీస్ ఆర్ ద parameters that make you to go for the general parameters over here, my dear friends. Okay, similarly next, with that we had concluded about the LDR and its parameters, my dear friends. Okay, similarly I am going for the next device, and this particular one is called PN photodiode. Okay, now we have finished, my dear friends, in a detailed manner. Okay, we have finished in a detailed manner regarding the PN photodiode and its parameters in a detailed manner. Now in this particular section we are going for the one more important device. Okay, what is that particular device? Let me go for in a detailed manner over here. Okay, so what is that particular one? Okay, PN photodiode. Okay, LDR. Okay, what is the one more important parameters just I am going to tell you itself is that the summary of the LDR is pretty important over here. Okay, LDR, symbol of photoresistor, Okay, ఇది జనరల్గా this is a LDR, means here what happens, see, no PN junction. LDR is a less sensitive, there is no PN junction, it is made up of only a semiconductor material, no PN junction, my dear friends. Second one, it is made up of semiconductor material. Next one itself is, it is a passive element. Passive element means it is a energy absorbing element. Means it is absorbing the complete energy, my dear friends. Okay, and these are all the parameters that make you to go for what, my dear friends, to go for the usage of these particular, okay, photo diode, my dear friends. Okay, similarly, okay, my dear friends. Okay, similarly, photodiode, PN photodiode. Okay, next one is PN photodiode. How it will be there? How it will be there, my dear friends? Let me check it. PN photodiode. Wait a minute, my dear friends. PN photodiode. So in this particular PN photodiode, my dear friends, I am going to take a P-type material and N-type material. P-type material and N-type material, my dear friends. This is a P-type and N-type material. Very, very important, my dear friends. Over here, how we are connecting the P-type material. This is what, my dear friends, a P-type semiconductor and a N-type semiconductor. Okay, listen carefully here. Generally, if these photodiodes are always connected in the reverse bias, my dear friends, see here, this is also we are connecting the reverse bias V naught, my dear friends. See here, a light is projecting. Okay, see, incident photons of energy means this is a PN photodiode since it is made up of the P-type material and N-type material, my dear friends. Okay, a light is projecting. See here, energy E is equal to H in U, my dear friends, which is projecting, okay, on this particular one, okay, on this particular LED, and this one is a depletion region. Okay, this one is a depletion region, my dear friends. When a light is projecting on this photodiode, more amount of the light is absorbed. More amount of the light is absorbed inside, my dear friends. Not only if that is depletion region, a little bit of the light is absorbed inside the outside region, my dear friends. Okay, about this particular figure, my dear friends. Okay, so that particular indication means more amount. The more amount means the light is absorbing more inside, like this, my dear friends. Okay, it is like this. Like this, my dear friends. Okay, this one is optical power. Optical power, my dear friends. Okay, similarly, అంటే ఇక్కడ ఏమైతుంది, లైట్ ఎప్పుడైతే దీన్ని ప్రొజెక్ట్ చేశానో మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఈస్ అబ్జార్బ్డ్ ఇన్సైడ్ ద డిప్లీషన్ రీజన్ అండ్ లెస్ అమౌంట్ ఆఫ్ ద లైట్ ఈస్ అబ్జార్బ్డ్ ఎట్ ద outside this particular region, my dear friends. Okay, then valla automatically what happens, my dear friends, that I am going to represent over here. See, then the photons absorbed within the depletion region. అయితే ఎప్పుడైతే ఈ ఫోటాన్స్ ని ఇక్కడ మోర్ అమౌంట్ ఆఫ్ ద లైట్ ఈ డిప్లీషన్ రీజన్ లో అబ్జార్బ్ చేసుకుంటుందో, ఈ డిప్లీషన్ రీజన్ లో వాట్ హ్యాపెన్స్, మై డియర్ ఫ్రెండ్స్, it generates what, my dear friends, electron hole pairs. It generates the electron hole pairs, my dear friends. Okay, electron hole pairs. Electron hole pairs. Okay, electron hole pairs. This is electric field. Electric field, my dear friends. Okay, this is the general parameters. So ultimately what I am going to do, suppose a energy of the light, okay, incident photons of light is h nu, he is projecting on this one, then what happens, more amount of the light is absorbed, a less amount of the light is absorbed over here, then what happens, means more and more electron hole pairs are generated because of the built-in this strong electric field, my dear friends. Electron and hole pairs, because the strong electric field that is present, because the immobile here, what happens, here immobile negative ions and here immobile positive ions. Okay, because of the built-in strong magnetic means electric field, my dear friends, then what happens, these electron hole pairs, my dear friends, are moving. Okay, means they are accelerating with a drift, my dear friends. Okay, there will be a drift of these charge carriers on this side, so this side and again to this side, my dear friends. Okay, so ila veltayi, otherwise that will be drifting of this n side and to the drifting to the p side, my dear friends. Okay, so when there is a drift, because I am going to give this electric field, because of this particular electric field only the drift of the charge carriers is going to be taking place. The drift of the charge carriers is going to be taking place, my dear friends. Okay, and the resulting flow of the photo current is called, okay, and the resulting flow of the photo current constitutes, okay, the response of the photodiode. Okay, so the resulting flow means ultimately because of the strong electric field, okay, that is, okay, that is present electron in holes gets generated inside this region, get accelerated in opposite redirections, thereby drift of n side and p side. The resulting flow of the current constitute a response of the photodiode. Okay, the result whatever the drift is taking place because of the this particular more amount of the power, my dear students. Okay, whatever the response time, and that is given by that response that is given by this is time is called tau, that is given by the tau drift, my dear students. And W itself is the width of the depletion region, this is called W. Width of the depletion region is W, my dear students. Okay, and the velocity, okay, the drift velocity, okay, it is moving, the charge carriers are moving with the drift velocity, V drift, my dear students. Okay, then you are getting the various parameters over here. So what kind of parameters you are going to get is, that is also very, very important. Okay, so ultimately and that one, generally what is velocity? Velocity equal to very, very important parameters, distance by time. Okay, here what is tau? Tau is equal to time, that is tau drift. Here in case of it's nothing but time. And here d is nothing but here W. Okay, and V is nothing but V drift. Okay, now he is asking what is this time? Time equal to what happens, my dear students? D by V. So here also this time equal to tau in terms of drift, which is equal to W by V drift. V drift, my dear students. V drift, my dear students. Okay, and W is the width of the depletion region, and V drift is average drift velocity. Okay, average or the drift velocity, my dear students. Okay, and this is the depletion region and average or drift velocity, and always this drift time is how much, means always it should be of 100 picoseconds, 100 picofarads. Okay, and also we know that the width of the depletion region, because I told you here the two regions are there, P side it is of acceptor concentration and it is of ND, donor concentration, my dear students. Okay, similarly that is equal W equal to VBI plus V naught into 1 by NA plus 1 by ND, my dear friends, which is equal to 1 by 2. So here whatever the width you are going to get is this is the formula already built in potential, and this is applied voltage, my dear friends. NA is acceptor concentration, ND is donor concentration. I already told these particular parameters, my dear friends. Okay, NA and ND, my dear students. Okay, then here ultimately what I am going to tell you itself is that this is whatever the drift velocity you are getting is pretty important over here. Okay, and this particular velocity itself is the important parameters. Okay, so ultimately okay, this is W, my dear friends. Okay, so here one more question is asked. What is this? Here what is the drift? See, already the drift velocity. Okay, V drift is directly, if it is coming this side, V drift, my dear students. Okay, is directly proportional to width of the depletion region, and I told you that V drift, okay, is nothing but the width of the depletion region, but width of the depletion region is directly proportional to the, that is built-in potential, my dear students. Okay, so here also, my dear students, what ultimately the applied, this is applied bias voltage is V0. It is both proportional to applied bias voltage and both parameters, my dear students. Okay, then automatically V drift, okay, that is W equal to what, my dear students, you are going to get in this particular fashion. Then automatically V drift, okay, so is directly proportional to inbuilt potential plus applied voltage, my dear friends. Okay, applied, that is particular parameters, we need to take it over here, my dear friends, as far as the general things are concerned. Okay, అంటే ఇక్కడ ఏం లేనా మనకు ఆల్రెడీ ఇది వచ్చింది దీంట్లో, అంటే దీంట్లో వచ్చి ప్రపోర్షనల్ తీసుకొచ్చాను. వీడు అడిగాడు V drift is directly proportional to W. Again W is directly proportional to E parameters. Okay, then V drift is directly proportional to E parameters, my dear friends. Okay, in that way you are going to get over here, my dear friends. Okay, then the drift velocity depends upon the bias voltage, but attains a saturation value. It attains a saturation value depending on the material of the diode, depending on the material of the diode, my dear friends. Okay, similarly, okay, these are the general things, just I would like to bring it to your notice, my dear friends, as far as the today's concept is concerned, my dear friends. Okay, similarly, when a light falls, very very important questions. When a light falls on a photodiode as shown in the following circuit, the reverse saturation of current of a photodiode changes from 100 microamperes to 200 microamperes. Assume the op amp to be ideal. The output voltage V of the circuit changes from dash to dash. Dash to dash, my dear friends. Okay, this is what. Okay, he has given the question and he has given the diagram, my dear friends, in this particular fashion. And this is V only given, my dear friends. This is the current that is passing over here, plus or minus. This is what, 10 kilo ohms. He only given the current that is passing is IP, photon current, my dear friends. This is okay. What he has given is the VA. VA, my dear friends. Four kilo ohms. This is VA. This is 2 kilo ohms. And this is 12 volts, my dear friends. Okay. This is what I am going to tell you. See here. $2K, and this is 2K, my dear friends. This is 4K, 12 volts. Like this, this is 10 kilo ohms. You only given 2 kilo ohms and 2 kilo ohms, 12, and this is a photodiode he has given, my dear friends. Okay, and his question itself is that now he is asking that what is this, the IP first, the IP current is, this is VA. He has given first find out the IP, my dear friends. Okay, IP equal to this V minus VA, V minus VA divided by 10 kilo ohms, divided by 10 kilo ohms, my dear students. Then V equal to IP into 10 kilo ohms plus VA, my dear students. 10 kilo ohms into VA, my dear students, and VA equal to what is the value of VA? Now we are finding out the VA, my dear students. VA equal to V into R1 divided by R1 plus R2, voltage divider network. So what is the voltage V here? It is 12, my dear students, okay, which is equal to 12 into 4 divided by 2 plus 4, my dear students, which is equal to 12 into 4 by 6, my dear students, okay, which is equal to 8, my dear students, okay, and VA equal to 8 volts, okay, VA equal to 8 volts, my dear students, okay. You are going to get this particular VA value. Okay, you got it, how I got the VA value? Because I want to bring back the VA value. Okay, see, to find out the capital V value. Okay, I want to bring back this value. He is asking what is the output voltage. He has given that is photodiode changes from 100 microamperes to this IP value is changing from this one to this one, and when IP value is changing, my dear students, he is asking what is the value of the voltage, my dear students. He is asking what is the value of the voltage, okay, over here. Okay, similarly, over here, my dear friends, okay, similarly. సో దీనివల్ల మనకి ఏమవుతున్నాయి, VA ఈక్వల్ టు 8 volts. సో ఇది వచ్చింది కదా మనకి. నెక్స్ట్ ఏం చేయాలి, మనకి V కావాలి. మనకి ఆల్రెడీ వీఆర్ హ్యావింగ్ ద ఫార్ములా, ఈ ఫార్ములా ఉంది కాబట్టి మనం ఇక్కడ సబ్స్టిట్యూట్ చేస్తాం ఆల్రెడీ. సో మనం ఈ పారామీటర్ అనేది తీసుకొని వస్తాం. ఈ ఫార్ములాని నెక్స్ట్ పేజ్లో వేసుకోండి. సబ్స్టిట్యూట్ ఇయర్ VA వాల్యూ, IP వాల్యూస్ వేసుకున్నాను. సో అల్టిమేట్లీ V equal to IP, my dear students, into 10 kilo ohms plus VA. Then IP is changing, my dear students. Okay, already we got the VA equal to how much? 8 volts. Therefore, now I am going for the IP equal to first one is 100 microamperes. Substitute here. V equal to 100 microamperes into 10 kilo ohms plus 8 equal to 9 volts. 9 volts. Similarly, IP equal to 200 microamperes. V equal to, my dear friends, which is equal to how much you are taking? 200 microamperes plus 8, which is equal to 10 volts, my dear friends. Then the voltage changes from 9 volts to 10 volts, my dear friends. Okay, 9 volts is for IP equal to this particular parameter, and 10 volts is for, my dear friends, that is 200 microamperes. Okay, this is what I have depicted over here, my dear friends, in a detailed manner. Okay, I have depicted in a detailed manner, my dear friends. Okay, similarly, సో మనం ఏం చేసామన్నా, వీడి డయోడ్ ఇచ్చాడు, ఈ డయోడ్ ఇచ్చిన తర్వాత వాడు ఈ పారామీటర్స్ ఇచ్చాడు, ఐపీ వాల్యూ ఇక్కడ చేంజ్ అయితే వోల్టేజ్ ఎక్కడి నుంచి ఎక్కడ చేంజ్ అవుతుందని అంటున్నాడు. ఓకే, సో వాట్ ఐ హావ్ డన్ మై డియర్ ఫ్రెండ్స్, ఫస్ట్ ఐపీ ఈక్వల్ టు అంటే ఐపీ యొక్క రిలేషన్ తీసుకొచ్చాను, అంటే వి ఇది మైనస్ విఏ బై 10 కిలో ఓమ్స్, దీంట్లో నుంచి వి వాల్యూ బయట తీసుకురండి అన్న, విఏ ఈక్వల్ టు వి ఇంటూ R1 బై R1 ప్లస్ R2. ఓకే, దిస్ ఈజ్ వాట్ యు ఆర్ గెటింగ్ ఓవర్ హియర్. అప్పుడు విఏ ఎంతనా 8 volts. ఓకే, విఏ 8 volts వచ్చింది. ఓకే, అల్టిమేట్లీ సో ఐపీ వాల్యూ వచ్చింది కదా, this is what you are getting my dear students. Okay, similarly one more problem. Now my dear, another question my dear friends, the effective area of the photodiode, the effective area of the photodiode my dear friends is very very important. Okay, what is the effective area of the photodiode? He has given itself is 0.4 into the effective area of the photodiode he has given my dear friends is 0.4 my dear friends into 10 power minus 6 meter square. Irradiance equal to 300 watt per meter square. Calculate the incident power. Calculate the incident power. A equal to 0.4 into 10 power minus 6 meter square. Okay, and what is I value? I equal to 300 watts per meter square. Okay, then power equal to A into I. Okay, A into I itself is 0.4 into 300 into 10 power minus 6. Okay, which is equal to 120 microwatts my dear friends, which is equal to 120 microwatts. Okay, the formula for the irradiance I told you, the irradiance formula is equal to power by okay area. Okay, now he is asking this incident power, okay, which is equal to intensity. He only given intensity is nothing but the irradiance, and area he has given my dear friends, he only given the area for this particular one over here. Okay, similarly like that we have done this particular problem over here my dear students. Okay, similarly next question, he has given a photodetector circuit. He is given by the photodiode has an active area of 10 power minus 2 centimeter square and a sensitivity of 0.55 ampere per watt. When a light of intensity this one falls on the photodiode, the output V0 equal to, the output V0 is equal to is asking. He has given my dear students the parameters, he has given the area, he has given the area is 10 power minus 2. Okay, which is equal to 0.01 centimeter square my dear students. Okay, S is equal to 0.55. This is what sensitivity, output by input. Okay, what is we are going to take it, the input is power, output is what, this one current my dear friends. Okay, he only give this one. Okay, S is equal to, okay, this one is very very important my dear friends, and the current light intensity which is equal to 10 milliwatt my dear friends per centimeter square, per centimeter square. Now what is the voltage my dear friends? What is the, that is voltage you are going to get. Okay, first one itself is very very important, is that the formula for the sensitivity. The sensitivity I told you is output is what, the output is always the current IP. Okay, and input I am going to give light in the form of power, power equal to, but what is the formula for the power? Okay, power equal, I told you, irradiance equal to P by A, then power equal to A into I, A into I my dear students. Okay, A into I. Therefore what I am going to take it over here, so what are the parameters he has given is this one, so IP by A into I my dear students. Then S equal to what kind of parameters you are getting? Okay, S equal to I. What are the value of I you are getting? IP we need to find out. Okay. First find out the IP from this one. So sensitivity you only given how much? 0.55. Okay. Which is equal to what is IP value? We need to find out. Then A into I. 0.01 into 10. Okay. 10 m, my dear students. Okay. Then automatically IP equal to 0.55 into 10 power minus 4. Okay, this is what you are going to get over here. Okay, the IP value, because area we have substituted. Okay, I also we have made it over here. 10 milliwatt we have done over here. Okay, I is the intensity. This value also we have written. Then you are getting the IP value, my dear students. Okay, this is you are getting the IP. But from this diagram, see here, this is 0 volts. Okay, then the current is closing here IP, my dear students. Okay, and the output voltage is here V here. He is asking the output voltage, what is this V naught? He is asking to calculate this particular V naught. IP equal to 0 minus V, okay, divided by 100 kilo ohms. 100 kilo ohms. 100 kilo ohms. Okay, then automatically whatever the value you are getting, okay, this is the output voltage. Okay, so the output voltage substitute here, IP you are getting, then output voltage equal to minus 100 kilo ohms into IP, my dear friends. Then V equal to IP value already it is there, 100 kilo ohms is there, minus 5.5 volts. This is what you are going to get, my dear friends. Okay, the values that you are going to get. అంటే ఇక్కడ వాడు ఇచ్చింది ఏంది, సెన్సిటివిటీ ఇచ్చాడు. ఫస్ట్ మనం ఐపీ కనుక్కోవాలి. ఐపీ కనుక్కోవాలి కాబట్టి పవర్ ఇచ్చాడు, ఇంటెన్సిటీ ఇచ్చాడు, అన్ని ఇచ్చాడు. సో ఇవన్నీ వచ్చిన తర్వాత మై డియర్ స్టూడెంట్స్, యు ఆర్ గోయింగ్ టు గెట్ ద అవుట్పుట్ వోల్టేజ్. ఓకే, you are going to get the output voltage, my dear students. Okay, over here. Okay, similarly this is about this particular diode, my dear students. Okay, whatever the till now diode had been explained, my dear students, is very very important over here. అంటే మనకి క్వశ్చన్స్ అనేది different parameters లో మనకు అడుగుతారు నాన్న. Okay, now very very important question, one more question itself is that మనము okay, one more important question that is asked optical sources లో. Okay, ఆప్టికల్ సోర్సెస్ అనేటివి మనకి ఎన్ని సోర్సెస్ అని చెప్పాను? హౌ మెనీ? 5 సోర్సెస్. అంటే దాంట్లో ఫస్ట్ ఏంది, సన్లైట్, సెకండ్ వన్ ఇన్కాండిసెంట్, థర్డ్ వన్ ఫ్లోరోసెంట్, fourth one LED, fifth one lasers, my dear students. Okay, so దీంట్లో మనకి ఫ్లోరోసెంట్ అంటే మనం ఇన్కాండిసెంట్ అంటే ఈ సోర్సెస్లో వాడు అడిగే క్వశ్చన్, మై డియర్ ఫ్రెండ్స్, he has asked a beautiful question over here. Okay, what is that, my dear friends? Okay, he has asked the question, what kind of the filament we are going to use as a incandescent source. Okay, generally incandescent sources అంటే ఎలా ఉంటాయి, my dear friends? Okay, incandescent sources అంటే if you are going to take it, this is ఓకే, ఇన్కాండి సోర్సెస్లో ఈ టంగ్స్టన్ అండ్ ఈ టంగ్స్టన్, మై డియర్ ఫ్రెండ్స్, ఇది టంగ్స్టన్తో తయారు చేస్తాం. okay, internally, and it is filled with the gases. What type of gases? Inert gases, my dear students. Inert gases ante it depends upon the formula of what? Incandescence. Incandescence we did. So దీంట్లో అడిగిన క్వశ్చన్ ఏంటంటే ఇన్కాండిసెంట్ సోర్సెస్ లో ఏం వాడతాం అంటే టంగ్స్టన్, మై డియర్ స్టూడెంట్స్. ఓకే, టంగ్స్టన్ ఇస్ అ ఫిలమెంట్ అండ్ దీని యొక్క మెల్టింగ్ పాయింట్ ఎంత అడిగాడు అంత అంటే 3400 degrees centigrade, my dear students. Okay, hope that we have finished the today's session, my dear students. In the next session I am going for the PIN photodiode and all the parameters in detail, my dear students. Okay, finally, so other diodes gurinchi chesesi we are going for the completion of the subject, my dear students. Okay, similarly Facebook, Unacademy, the Instagram, Telegram, the number of followers are day by day increasing. Unacademy Telugu channel, you are going to access the subject in 2 languages, Telugu and English. And Unacademy #1 study channels are there where you are going to access subject for different different competitive examinations, my dear students. Similarly, thank you very much for attending this particular session, my dear students. Finally, thank you.